Hello, my name is Stacey Mankoff. I am managing principal of the Mankoff Company and also founder of After the Bell events. And I'm delighted to welcome you to another edition of the Bellringer. And this one is, we have Adi Ben-Ari, who is the founder and CEO of Applied Blockchain. And Adi is going to speak about the development of confidential computing. Now, Adi has over 20 years of enterprise software experience and most recently leading major delivery of production blockchain and advanced cryptography solutions. He is widely recognized as an independent thought leader in the industry, a noted speaker at major conferences, including our After the Bell events, which, as everyone knows, is on pause, but we are most certainly hoping to start them up again the second half of 2021. Adi is also experienced in educating C-suites on blockchain, confidential computing, which is what we're going to be discussing today, and privacy-preserving technologies. He acts as an advisor for a number of startups, and his work has been noted by the UK government, where he was invited to present at Parliament and the House of Lords. So welcome, Adi.
Thank you very much, Stacey. Great to be here.
Great to have you. Is there anything else you'd like to add?
No, I think I think you've covered quite a bit there.
I know. And as some of our audience knows, Adi has spoken at a number of our events, and he's speaking to us from London today. First off, how do you define confidential computing?
Yeah, so confidential computing is kind of an evolving branch of computer science and area of software development. And it's basically the ability to run, to have store data and run computation in a part of a computer which is secured. If you think about it, it's got like a ring fence, a wall around it within the computer, so that even the operating system itself, or someone, an administrator, or even someone with physical access to the device, wouldn't be able to get in and get to that data. So it's basically a security technology, but it allows you to section off a part of the computer, and it could be a server, it could be your computer at home. We actually already have this on our mobile devices.
Oh, okay.
And so it's now expanded to different types of computers, and we can now develop applications where part of the application runs inside this type of environment.
So it's very malleable in the fact that it can be used in computers of all sizes then.
That's correct. So it's already, as I mentioned, it's already present in our mobile devices. So that, those of you who've got an Apple device and might be using Apple Pay, the key that's used instead of your credit card number is a key that sits inside your device, and it's created in and guarded by the hardware of the chip, of the Apple chip, and that means that nobody can get to it. Apple can't get to that number, right? They would have to destroy it and create it again on a new device or a new chip. Nobody can actually get the number out. But the number, but whatever's in that hardware secured environment can be used. You can use it to sign and to run computation and do other things. So it's just this extra protection that's very, very hard to breach.
I'm going to ask a question that why would you need that extra protection?
Yeah, so it's an interesting question. So I mean, first of all, in today's world, there's so much data flowing around, and it's our own data and it's our company's data, and it's being passed around as we do business, sometimes knowingly, sometimes not knowingly, and it's sitting with various organizations, and there are breaches happening. Every week there's another headline for a major organization that suffered a cyber breach, and most, if not all, of the customer data has leaked. So for that reason, we're looking for more security. We're looking for more secure solutions. Now, those familiar with computer science and technology, we've always had software and hardware.
Yes.
And software is you can write programs and you can code. And actually the things that are available and protected through software, they can also be breached and overcome through software. So hackers can write software, they can embed things inside existing software, and it's easier for them to penetrate. Where there's a hardware layer providing protection, that's a harder thing to break. That's a harder thing to get through.
Okay.
And so that's really what this is about. This is about providing that extra level of security.
Mm-hmm.
Now, the interesting thing is you could put something in there for safekeeping, but the interesting thing is that you can create things in that type of environment that are never exposed to the outside world, and that's you can think about that example with the Apple key. So it's a
Okay.
key that's created on Apple device that
Mm-hmm.
nobody ever sees. Apple software can't get to,
Mm-hmm.
and we can't get to either. But it's there and it's
Mm-hmm.
used to identify you, to sign your card, and so on. And so what we're starting to see with confidential computing is companies that are hosting services
Mm-hmm.
on behalf of other people with other people's data. And so they can run the service, they can offer the service, but they can't see what the data is
Mm.
because it's running on their servers inside this secure environment.
Mm.
Right?
So that's really something, and I am sort of jumping ahead, but um, I mean, this sounds like it would be a perfect application for records, including like health record, all these things that need to be very private and very secure.
Yep. Yep, that's correct. What we find with privacy technologies is
Mhm.
the technology is usually quite black and white, right? Something's private or it isn't, and some data is exposed.
There's no gray area in privacy.
That's right. Well, that's it. In technology, though, if you're a technologist like me, then it's all black and white. But when you get to the real world, it's not.
Right.
So, I mean, with healthcare, obviously, there's some parties that you want to share it with. There's others that you don't.
Right.
The problem with data is that as soon as you share it, it's out there, right?
Mm.
It's not, it doesn't have an antenna on it that says I'm over here now, I'm over there,
Mm-hmm.
and so you can't really track it, and actually you can't stop it being replicated. So
Mm.
once the data has been shared with someone, then you've lost control of it.
Got it.
And so you can have regulation, and you can have policies, and you can have ethical behavior and best endeavors and so on. But technically,
Mm-hmm.
that data is out of control.
Mm.
Right?
Okay.
Once you've let it out of your own area of physical control. And so what we're starting to look at with this technology is, can we, instead of letting the data out, can we enable queries to be run on the data or some kind of activities to be run on the data that other parties require without actually handing it over to them?
Hmm.
Right? So
Mm-hmm.
can we bring them to the data and let them do things without actually touching it and seeing it, rather than having to hand everything over for everything that we do? And that we believe will much better protect the data.
Mm. Now, you are one of the blockchain experts. So what is this blockchain application?
Yeah, so the link to the blockchain. So first of all, what we've seen, we've been in the space for 5 years developing
Mm-hmm.
applications,
Mm-hmm.
primarily for enterprises, for corporates. That's kind of my background,
Mm-hmm.
and that's been our area of focus. Now, the blockchain is a distributed ledger,
Right.
and as soon as you distribute some information or database between different parties, the first requirement that comes back is, right, how do we stop this other guy seeing my business, that I'm doing with someone over
Mm-hmm.
there?
Mm-hmm.
And so data privacy was something we had to look at from day one.
Mm-hmm.
And it wasn't something that was inherent in certainly the first generation of blockchains that became available.
Mm-hmm.
So this privacy technology, including these confidential enclaves, is something that's kind of really been accelerated through the development of blockchain and through the fact that blockchain has been adopted and experimented with in so many different areas.
Mm-hmm.
So the two of the two types of technologies have really grown hand in hand. Now with a blockchain, because you're distributing on the one hand, you're distributing the ledger. The
Mm-hmm.
reason you're distributing the ledger is typically that you want more than one party to validate and secure the ledger itself, the historical integrity,
Mm-hmm.
right?
Mm-hmm.
That's the whole principle of the blockchain, right?
Mm-hmm.
Added security through a group of validators. And so the technical problem has been, how do you stop those validators from knowing everybody else's business?
Right.
All of the business that's being conducted on the blockchain.
Mm-hmm.
And so there's two classes of solutions for that. One class is kind of software-based cryptography, which says we're going to encrypt this data, but we're going to encrypt it very cleverly in a way that still allows some sort of verification of it. So the
Mm-hmm.
parties that hold it can still verify that it's actually, the integrity is there, but they can't see what's going on. And that area of exploration is known as primarily through a technology called zero knowledge proofs. Right?
Zero knowledge.
Zero knowledge proofs.
Okay.
So I can prove something without knowing anything, or I can validate something without knowing anything about it. Right? I can just validate certain properties of it. And so you could imagine someone hosting a blockchain ledger where they know that the number of tokens or coins is correct. The total number of coins is correct.
Right.
And that all the wallets add up correctly and all the movements of funds make sense, but they don't know who's got what. Right? And they don't know who the parties are. They can't see anything. Right? All they know is that all the totals add up. So that's one way of solving it. And another way is these secure enclaves. Right? So what if you hosted a blockchain node in the ledger inside one of these hardware enclaves? In that case, you could have validators who are basically hosting parties. They've got their machines that they're hosting and guarding. Inside those machines, there's a blockchain running inside one of these hardware secure environments. They can't see what's inside, but the machine, the way the enclaves work is it'll prove to the host that everything is running correctly. Right, so you know that that there's no, there's nothing being deleted, there's no theft going on, there's nothing that isn't allowed in the rules of the blockchain. You know that the rules of the blockchain are being kept, but you can't see the data. Right, and so that's where these two things overlap. Okay.
So this all sounds terrific. I mean, it sounds like a no-brainer. It sounds like, what are you finding, if any, is the pushback on this? And, are you also having any regulatory issues?
Yeah, so I'd say if you look at the two class of solution that I described, they also fit into the two classes of blockchain, if you like. One of which is the public cryptocurrency blockchain, the Bitcoins, the Ethereums, and all their brethren. And then on the other hand, we have the enterprise blockchains, which are generally running, and again, it could be an Ethereum Quorum, a sort of blockchain more suited to enterprise uses, or a Hyperledger Fabric or a Corda. So these are the enterprise blockchains. Now they work very differently, and so the privacy requirements, because of the actors, because of the types of actors, the privacy requirements are different. And so what we found is that in the public blockchain, where you really don't trust anybody, the software-based solutions like the zero knowledge proofs are the solutions that are taking hold.
Okay.
Right. So we have cryptocurrencies like Zcash, which was really the pioneer of the zero knowledge proofs, and we have various others which have evolved since, and we have the same technology being applied on top of Ethereum and other ledgers. So they're going for the software-based approach. Right. They also have a very large number of nodes, and networks are typically large. But then in the enterprise space, I think the secure enclave technology is potentially more suited, because you've got less actors. They're much more privacy conscious. They don't want to see each other's transactions, and this type of technology is just really more suited to them. So that's how we see the split. Where we see, you talked about resistance or issues. I think this is this is like
next generation.
It's almost a next generation problem. Right. So most large organizations are still grappling with, what is this blockchain? What's it really going to do for me? How do I engage with it?
Yes.
And even if they're building and doing proof of concepts, and even if they've got solutions into production, they're probably still grappling with the very concept, right? And the value it might bring to them. And so the truth is that most enterprise blockchains are not really distributed yet. Right? I actually heard somewhere else, I think the average number of nodes in the private network is 1.5. Right. So you can learn from that, and the reason for that, I think, is because of this trust privacy between large organizations, that it's very, very hard to break through. Right? Why would I do something with other companies where we're sharing the same infrastructure, we're co-owning it, and we're co-running it, and we're co-taking responsibility for it? It's a very difficult concept for organizations to really embrace. And so I think it's only those that have really gone far into that then need to solve the privacy problems.
Okay.
So it's you have to be quite far down the maturity, let's say the blockchain maturity route, to even have this as a class of problem that's bothering you yet.
Gotcha. And I don't know if you feel, but can you share with us before we go, like an example of somebody who's using it and what they're using it for?
Yeah, I can tell you, we're exploring it with customers, and we're looking at
any industry, any particular, any industry.
I can tell you that we've looked at markets such as commodity markets, energy, shipping, where this could be used for marketplaces.
Okay.
Right. So you have marketplaces where parties want to meet, they want buyers and sellers to meet and be matched, but they're maybe nervous about exposing commercial information to third parties. Right. And so this is a technology where you could potentially solve that while hiding or preventing somebody from being able to get too much information and maybe misuse it or use it to their advantage. So this is really a way of kind of really managing that information well, right? And having the not just the software but also the hardware protect against misuse of your commercially sensitive information.
Yeah.
So we've looked at it in marketplaces in particular, as I said, shipping and energy. We're also exploring. We have a project in the travel industry, which is exploring this. You talked about healthcare. We have had a couple of partners, clients that we've looked at this for healthcare as well. And yeah, we think that I'd say in general, a lot of people when they looked at blockchain, they made a lot of assumptions about it, which many of which I would challenge now. And many solutions just brought developers and said, right, let's put this whole thing onto the blockchain. And I think that's completely the wrong approach. And what we've ended up with is a lot of data on blockchain solutions. And I think that's not the place for data. Right? So where is the place for data? Well, actually, these types of environments. Right? So you could have the data that's being used in a multi-party solution could sit in this type of secure, confidential computing environment where it's really well protected. And then the records of assets, asset ownership, trading, transacting, really that moving around of assets, money, ownership, and so on, that's the stuff that should sit that can sit in the blockchain. And that's what the blockchain is really, where it brings value. So, I would argue for that separation.
Yes. Well, it certainly sounds like a more secure environment than what's in place right now with our information.
Yeah, I'll definitely second that. I think something needs to be done.
Well, Adi, thank you so much. As I said, I wanted to give people a taste of this as we will be exploring this topic and many others, hopefully sooner rather than later when we can all be together again in 2021. So once again, Adi, thank you so much.
Great. Thank you very much, Stacey. Pleasure.
Bye-bye.
Bye-bye.